Thank you. Well, good afternoon, ladies and gentlemen. Thank you to stay here. I will present you fire lifts, escalators, and moving walks management system in International Airport of Rome Fiumicino. Does it work? Excuse me. Okay. In January 2014, Airporti Roma the management decided to implement a fire safety system to lifts, escalators, and moving walks in the International Airport of Rome, Fiumicino, starting from G-Gates Terminal Satellite. The decision was taken by the facility manager at that time, and he called me and he told me, okay, I want to implement, because after an international safety audit, they decided to implement a safety system conforming to the EN 8173. The international safety audit decided they required only a system like this on elevators. And he told me, okay, I call you, I know you, and you can start everywhere when you want. I decided to start from G-Gate satellite because it's a terminal separated from the rest of the body of the airport, and it's easier to implement a prototype of this system, okay? There are only 45, as I can show you later, only 45 units to be controlled. It's called satellite because it's satellite, it's coming from Latin, of course. That's all. And he had it also that he told me I could call, for example, the multinational like Schindler or Siemens, but I prefer to call you because to ask you this task, because in 2 months or 2 years they can revert to me, this multinational can tell me, oh no, it's not feasible, we can't do it, so I prefer to call you. This is the situation in the satellite G-Gates, 28 elevators, most of 90% of them Schindlers, 70 escalators, Schindlers and 1 Paravia, 3 levels, divided by altitude above sea levels, 2 meters, 6.5 meters, and 11 meters above sea level, so 3 levels of the terminal, and 1,400 fire detection centers with one fire central unit Siemens. And I had also some hard requirements by the ADR management, by Aeroporti management. They needed an open hardware and software architecture. They don't want to be married to anyone, okay? And an automatic startup procedure like EN 8173, completely automated, without human supervision, and a high system reliability. I decided to implement components with a low probability of failure, so minus 10 elevated minus 6, 10 elevated minus 6. And they want also to reduce the probability of false alarms. And I decided to implement this procedure for elevators and also for escalators. Excuse me, elevators, lifts. A certain number of fire sensors are in fire alarm status at the same floor or in a specific area with a preset threshold value that will be explained later. So after it selects, the system selects automatically the evacuation floor, ignore or cancels the calls in and out, bypass the photocell with light barriers, of course not the safety contact of doors, go to the evacuation floor, open doors and stops. I want to point out, to underline that the evacuation floor is variable and not always the lowest floor. It depends on the fire. So if you have the fire in a certain zone of the airport of the level, a certain level, it decides automatically based on a preset matrix of the Gaussian, which is the safest floor, okay? For example, in the next project that I will implement in the airport, in the multi-level parking buildings of the airport, the safest floor, is not necessarily the ground floor. It could be, for example, the top level floor, where we have open space and there are many stairways, fireproof. So maybe this is the safest floor. We also implemented a procedure for escalators and moving walks. We have only escalators, but moving walks are accordingly. So, direction of motion, the opposite direction of the equation, stop the unit. Direction of motion, the same direction of equation, so it's favorable to evacuation, continue to run. Let's go, okay? I can anticipate also an answer that maybe you can ask in the next questions. If we have considered the possibility to invert the sense of motion of the escalator. We had a long discussion about it, but the decision was completely cancelled for two main reasons. In my paper, the first reason was that this could be a dangerous situation, contrary to the machine directive, because we are starting a machine without a human supervision, and this could be dangerous. The second reason is an historical reason, like in Italy, it's common. And just a moment. Some years ago, an old American lady was carrying her trolley in the American airport, in the airport of Rome, with a lot of baggages. She decided to climb up the escalator with the trolley. At the end of the escalator, the trolley turned around and killed the lady. And unfortunately, the old American lady was also the mother-in-law of the former American ambassador in Italy. The management at that time of the airport of Roma was beheaded, I think, in the public square for this reason. And the management of airport in Roma told me, I will never sign a risk analysis where I can allow you to invert the motion of an escalator in this airport. That's all. So this is the reason. And the other requirement was accomplished because they asked me to have an open hardware. So we implemented two PLC for safety reasons in hot backup, but they're industrial PLC and they're commercial. We used, in this case, a PLC Schneider Electric, but we could use everything that we want because the system is open. This firmware for PLC is open, and we have a standard communication protocol, in this case, Modbus TCP/IP. There is also another thing. We had open interface modules taken by Electroquadri and Hydroware with elevators and escalators on our technical specifications. And we also use an open SCADA, an in-touch system platform by Wanderer by Schneider Electrics. In this case, anyway, since the system is completely, preset and pre-designed, we could use everything that we want because we have the real specification. The hard part of the job was to get a standard protocol for the Siemens. There is another thing. We get the signal of the fire sensor directly from the fire central unit without passing the Desigo Siemens system, the fire system, the supervision system of the Siemens. That is based on Windows. So in this case, we have a more reliability on the software. I told you about the threshold value of the fire sensor, about the decision procedure. Not all the fire sensors are the same. So, for example, a smoke sensor can be more sensible to a false alarm. A thermal sensor is less sensible. So I decided the weight are fixtures, so some numbers are, But anyway, the decision procedure is in this way. I decided to assign a heavier weight to thermal sensor, a lighter to smoke sensor, and the heaviest to smoke thermal. So if maybe the sum of the weights is more than 1, 2, 3, everything, the parameter is variable. it triggers the system. And the sensors, for example, are inside the 10 meters radius. And all our sensors are in the same zeta coordinates, same level. Then you start the FEMS procedure. This is simply. I system reliability was accomplished at least still two PLCs not backup, with the probability of failure minor than 10 minus 10, two servers in out backup separated by 1 kilometers. The two PLCs are separated by 100 meters in different machine rooms, and 3 clients in remote control. There is also distributed logic with 7 independent input-output modules controlled by the PLC, connecting the closed loop to control separate clusters of elevators and escalators. In this case, each module controls a family, a cluster of 7 about units. And we have also one UPS that gives off 120 minutes of support in case of blackout. So, reduce the probability of false alarms. That procedure only if the sum of the weights of first sensor in alarm is greater than a threshold value. The sensors are in a circle of the determined radius. The sensors are the same level. This is a big issue in the airport because we have a loss of false alarms. False alarms are given by fire sensor in failure, for example, and the person is smoking under the fire sensors. This can happen. And they told me we don't want to stop all the units in the airport every 2-3 days. So find the procedure that's capable to avoid the threats. This is mainly the scheme of the FEMS supervision system. I'm sorry that I cannot give you more details about this system and the airport layout for security reasons mainly, and industrial reasons, of course. But anyway, this is system. This is one of the solutions that we found because we were capable to have standard interface. They told me electroquadri and hydroware, electroquadri mainly, a controller producer, Italian controller producer, that it was capable to produce a standard interface since we have the updated wiring diagrams. It was complicated to get the updated wiring diagrams for Schindler, but we got it. And that's all. We produce a standard interface, that is standard. This is a small layout of a terminal. You can see the yellow squares are each one of them is an elevator with a status. And this is the visual FEMS SCADA that we have. As I told you, we can use all the SCADA that we want. This is free. The FEMS will be installed in the system will be installed in the other terminals of the airport of Fiumicino. And 5 days ago, I have released the new project for terminal of domestic flights and B gates. They are the domestic flights. The system will control about 170 lifts now installed in the airport of Fiumicino. Now, 100 escalators and moving walks with signals coming from about 18,000 fire detection sensors. So, thank you very much for your attention.